Hey, what's up, guys? This is Chung here again. So this time, let's take a look at one of this week's Week City Challenge problems, number 1664, ways to make a fair array. So it's a media level. Okay, you're given like an integer arrays here, right? And then you can choose only one index and remove that element, right? Exactly one index and then remove the element. And notice that the index of the elements might change after the removal. So which means that, if we have this kind of array here, right? It doesn't really matter. So we have x, 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 right? And we can basically choose to remove any of those index here, okay? And then it asks you to find so after the removing the index, it asks you to check if the remaining array is a fair array. So a fair array is the sum of the odd index value equals to the sum of the even index value, and then returns the number of indices that you could choose such that after the removal, the number is fair. So what does it mean? It means that, let's say we're trying to remove an index from here, right? So we have a 0, 1, 2, 3, 4, 5, 6, and 7, right? Let's say, for example, let's say we choose to remove the index at number 2 here, okay? And after removing index number 2 here, so the remaining index will become to what? So 3 will become to 2, 4 becomes to 3, 5 becomes to 4, so on and so forth, right? And then it asks you to check, right? After removing this one, the the sum of the odd and even index if they're the same. And then it gives you some examples here, right? So for example, this one 2164, there's only one possible place where you can make this array a fair after removing that index. Okay. And then here's the constraints. As you guys can see here, the constraints are like 10 to the power of 5, right? So I mean, to start with, right? I mean, the most brutal force way is like to try to remove each of the index, and after that we scan the entire array and try to summarize the total for both the odd indices and the even indices. But obviously, the time complexity for this approach will be O n squared, which will be TLE. So that's why we need a better approach of that. Okay. So if you watch this array closely, right? Basically, after removing this number 2 here, so whatever after this 2, there will be, so all the even indices now becomes to the odd indices, and all the odd indices now becomes to the even indices. So that gives us a hint, right? Which means that if we know all the pre-sum at each of the places, right? If we, for example, if we pre-calculate all odd the pre-sum and the even pre-sum, okay? After removing these indices here, we will have like we have the pre-sum before these indices, right? And what's after this one, we just need to reverse whatever we have here, either for the odd and even. We just need to reverse we just use the odd pre-sum for the even, and then use the even pre-sum for the odd. That we can just use the O1 time to get the pre-sum, sorry, to get the sum for both the odd and even after removing these indices, right? So basically, and to do that, we simply just need to have create two pre-sum arrays here to help us store both the pre-sum, the odd pre-sum and the even pre-sum. So and let's do it here. So we have n equals to the length of nums, right? Okay, we have even pre-sum equals to this of n plus one. So here, the reason we're creating like n plus one size is because, you know, whenever we calculate the pre-sum, let's say for example we have this part of the array here, okay, and we need to, let's say for this one, let's say we want to calculate the pre-sum for the entire arrays here. So we have a pre-sum of this one. This is the pre-sum, and to get the pre-sum for this range here, we have to get the pre-sum at this location minus one, right? And if this location is zero, then this minus one will be out of the boundaries. That's why we do a plus one here just to handle this case here. Now let's populate that, right? So we have for I in num enumerate nums, right? So this one here, um, we have odd pre-sum here. Okay. So now let's check, right? If I do a mod, if this one is not zero, then it means that it's an odd number, right? It's an odd index. So we just do a odd dot pre-sum dot, you know, so here since we're like what? We are iterate the we're iterating the numbers here, right? I mean, so we have to use like the index plus one here. Do a plus one, and then we do a odd dot pre-sum dot I equals to the num, because the zero is reserved, right? So we should start from I plus one. Okay, and then here, so for the even, right? So for the even, which since the current number is the odd indices, so for the even pre-sum, we just inherits the even pre-sum from the previously one, right? So the reason being is that we have to also populate the even though the current index is odd, because you know later on we'll be using for the same indices here, we'll be using both the odd and even pre-sum. Okay, so else this is the for the other case, we can simply just copy and paste this one, but we have to reverse that, or like this. Even pre-sum dot I plus one equals to this even pre-sum I plus num. Okay, the other one is this. It's this one. Okay, so that's how we pre-calculate the odd and even pre-sum. Now we have answer equals 0. So we simply just loop through the each of the indices. Okay, but since I'm going to use the pre-sum, right? That's why I just loop through the range from one to n plus one. I mean, you can either do a from 0 to n, or a 0 to n minus 1, or you can do a 1 to n plus 1. Either way is fine. Just like if we are doing this one, we're assuming that this I represents the pre-sum, right? So that we don't, when we get the pre-sum, we don't have to do a I minus 1, right? So we have a pre-sum here, right? So the first one is 0, and we have let's say we have a number here. We have a 1, 2, 6, 7, and 8, right? So the pre-sum is like this. We have 0, now it's 1. Remember, we're starting from 0, right? So 3, 9, and 16, 24. Okay. So now we're looping from this place. This is 1, and this is n, right? So since removing the card one, we're gonna basically split this array into two parts. That's why I'm going to have a odd sum 1 here. So this one is going to be the odd dot pre-sum of -1. Sorry, I minus 1, because after removing this one, whatever before this one, the total is the I minus 1 pre-sum, right? So same thing for the even, sum 1 dot even pre-sum, right? And now the parts that's after the current I, right, which will be the odd sum 2, right, equals to the even. So remember, after removing this one, so we have to use the even pre-sum for the odd one, right? So pre-sum dot, this range, this is the range we're trying to get, right? So to get this range, we're gonna use the even pre-sum, the minus one, which will be the total, minus the even dot pre-sum of I, which is the pre-sum starting from here. That's the sum for this for the second part. Okay, and the same thing is for the even, but instead we have to use the odd, right? Okay, and then we simply just check, right? If the odd sum 1 plus odd sum 2 equal to the even sum 1 plus even sum 2, and then we just increase the answer by 1. Okay, in the end, return the answer. Okay, so let's run the code here. Okay, cool, and submit. All right, so it passed. Yeah, and so time and space complexity, right? Pretty straightforward. They're both O of n, because there's only a single loop here, right? Another for loop here. Cool. I think that's pretty much it is. It's a it's a pretty straightforward, like the problem for the pre-sum. As long as you can figure out after removing, I think the key point for this problem is that you have to realize that after removing the current one, right? Whatever after that removed index, the odd indices will become to even, and even becomes to odd. And after that, all you need to do is just the two pre-sum, and then you can just use those two pre-sum to quickly calculate the uh, the odd and even pre-sum after the remove. All right, I'll just stop here. Okay, thank you so much for you guys to watch this video, and stay tuned. I'll be seeing you guys soon. Bye bye.